Hello viewers, welcome to my channel, The Modeling Guy. Today we are going to look at one of the most important concepts in the finite element methods, that is the negative elements in finite element analysis, and we will look at why do they matter. In finite element analysis, the meshes, they're very important and we trust them to behave well, but sometimes they go rogue. So, welcome to the world of negative elements in finite element analysis. So, what are negative elements? They are basically elements with inverted geometry when there is excessive forces or deformation. Mathematically speaking, their Jacobian becomes negative. So in finite element analysis, the Jacobian is an indicator of the volume of the element, and once it becomes negative, that means the element is flipped or distorted in a physical space. So the next question is, how are negative elements formed? They are formed due to the poor meshing or sometimes large deformations if the material is too soft and when you have too excess of a force, or when there are some errors in the geometry, or when there are some geometry issues like sharp features where the elements are too small or where the forces are too large. So basically they corrupt the accuracy and stability of these finite element simulations, and basically that means your simulation will not be successful and will be stopped midway. Alright, so we now know what negative elements are. So why do they matter? Why should I care? Well, when you have negative elements in your finite element mesh, basically your solver might crash. It could yield some meaningless results or some non-physical stress matrix. So how to avoid these negative elements? So one way is to basically check the Jacobian once the finite element mesh is created. So Jacobian is a part of quality metrics, which also includes some of the others like angles, the sizes, aspect ratio of the different elements, as well as some of the other metrics that could be used to evaluate the quality of the mesh. So evaluating the mesh is really an important step before we can use that mesh for finite element analysis. Some of the other approaches could be just remeshing to once you determine the different quality metrics, and if you think the quality is not enough, we can remesh it for better quality, as well as there are some techniques that could allow smoothing of the meshes. So basically that means you are working on some of the bad elements in the mesh to make them a little better. And some of these approaches could be used when you have a finite element mesh and you have questions whether it has some bad elements that could turn into negative elements during a finite element analysis. So once the mesh is corrected using the different approaches discussed before, we can have much successful simulations. So with this, I'll stop the video. And again, thank you so much for your time. Please, for more such content, please like, share, comment, and subscribe for more such videos. Thank you so much, and definitely check out my other videos on my channel, The Modeling Guy.